Okay, today we're going to learn about scientific notation. You can see we have some huge numbers like the mass of the Earth. We also have some small numbers that we're going to investigate. So in science we deal with some very large numbers like the mole. We'll be discussing more about the mole throughout chemistry. We also deal with some small numbers like the mass of an electron. Wow. So imagine the difficulty of calculating the mass of 1 mole of electrons. If you had 1 mole and you were multiplying it by the mass, you'd get a really large calculation, something that would not even fit in our 4-function calculator. And it'd be hard to enter on any calculator. So, scientists have developed this scientific notation, which is a method of representing very large or very small numbers. We represent it in the form of m, which is our number between 1 and 10, and an integer, which is n right up there. And you'll see that is a superscript. So let's take a look at this number, a big number. And you may want to take notes here so that you have them in case you're not quite sure how to do numbers into scientific notation. So the first thing you want to do is insert an understood decimal point. We'll put it at the end of our number. Then we want to decide where the decimal must end so that there's one number to its left. Because if you remember when we're setting up our, we have our number m times 10 to our integer, this m needs to be between 1 and 9. That's why we want so that there's only one number to the left. So, there we go. Now we'll have one number to the left of where we move our decimal. Now we want to count our places. Erase this so you don't have to look at it. Count how many places you bounce the decimal point. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we want to rewrite it in the form of m times 10 to the nth. So we get 2.5 times 10 to the 9th because we bounced our decimal 9 places. Okay, let's take a look at a number that's smaller than 1. We've already got a decimal point. We don't have to insert 1 because there's obviously 1 here. And then we're going to go ahead and move our decimal so that's one number is to the left, like we did in the other example. So let's count our bounces. 1, 2, 3, 4, 5. Okay, and now let's rewrite our number. So it's in the form m times 10 to the nth. And we get 5.79 times 10 to the negative 5th. Notice the exponent is negative because our starting number was less than 1. Okay, that gives you the basics. Now let's take it one level more and look at how to make calculations with scientific notation. We're specifically going to look at multiplying and dividing. I do suggest you write down these rules. So, we already know what our form is for scientific notation. Just a quick review. Remember that number needs to be between 1 and 10. It's not equal to 10 if you look there. Remember that? That just means it needs to be less than 10. Okay, and then our n is an integer. Okay, so, rules for multiplying in scientific notation. Multiply the first factors, and then you want to add the exponents. So, the key there is add the exponents. I do suggest you write that down so you have the notes for tomorrow when we practice. Here's our example. Alright, it says multiply your first factors. So the first thing we want to do is do 2 times 3. I think you can probably do that in your head. And 2 times 3. And then we want to add our exponents. These are our exponents. And if we add 3 plus 2, and we get our exponent, again, we keep our times 10 to the 5th. So we'd have 2 times 3, which equals 6. So we've got 6 times 10 to the 5th. Okay, lovely. I've totally made the screen look ugly. Alright, so let's do another example. 6 times 10 to the 5th. Alright, again, we multiply our first factors. 6 times 3, which equals 18, and then we want to add our exponents. 8 plus negative 2. you can have a negative exponent, as we know. 8 plus negative 2 equals 6. So you'd have 18 times 10 to the 6th. Now, if you look at that number, hopefully you'll realize that is not in correct scientific notation. It is greater than 9. So we need to change that so that's when in scientific notation. Just your rule, follow your rules like before, put in your decimal place, and we want it to be with one number to the left of the decimal. So we move our decimal, bounce it over 1. So our correct number will be 1.8 times 10 to the 7th. Remember, if you're going to move your decimal point, you have to adjust your exponent. And since we moved it 1 space to the left, we need to make our exponent larger. So 1.8 times 10 to the 7th. Another way to think about it is if you're taking a big number, 18, and making it smaller, do the opposite to your exponent. Make that bigger. Okay. All right, your turn. Write down this whole problem in your notes and solve the answer using our rules. And tomorrow you'll be checked to make sure you have that example, and I'll check your answer as well. Okay, our next rules. For dividing in scientific notation, divide the first factor and subtract your exponents. So pretty straightforward. 6 divided by 3, that equals 2. Take your exponents, 3 minus 2, and we get our 1. Remember, always keep this times 10 to the... Okay, next example. 2 divided by 7. Okay, now we get a number that's less than 1, so we're going to have to make some adjustments. And then 8 minus negative 2 plus the opposite equals 10. So we've got, all right, we've got to move our decimal over.
Mr. Ely, could you unlock the side door so the parents could get in from the parking lot because it's
all right, so our answer needs to be between 1 and 9. So we've got 2.86 times 10 to the 9. All right, your turn. Make sure you write these in as well and put your answer. And sorry for the interruption. You know I'm at school all the time. All right. Hope you enjoyed this first attempt at Camtasia. What I want you to do, the last part of this video, what I want you to do is if you have any questions, write them down. If you do not have any questions, you need to write down one new thing that you learned, and we will check for that in your notes. Thank you.